Well, hi, and thanks for joining me here when we take a look at another 50-pound oscilloscope here. This one is a Tektronix. The last one we were looking at was a Dumont. So I think you'll see quite a difference when I open it up in the style of the construction that was done on it. Now, this guy I've owned for a long, long time. I've had him since probably 1978, somewhere around there. And I used them until one day I turned it on and it didn't work right. And I set it aside. I had another scope, Heathkit one I had built. Not nearly the quality of this, of course. A Heathkit's a kind of a very amateurish sort of, I don't want to knock Heathkit, not knocking Heathkit here, but it just doesn't stand up to professionally built laboratory equipment like this. Tektronix 515A. Very, very common scope, by the way. So, I did try it once again. I turned it on probably 1995, somewhere around there. Came on, showed a display, and then in a matter of a few minutes, the display just winked out, faded out, and was gone. And that's all I've ever done. I've never tried to sort out the problem. I haven't run it since I haven't run it for 20 years. 20 years this has been just sitting in my basement, basically. So, I want to turn it right on, because I already know there's probably something wrong with it. Let's open it up and look inside. And it has not been stored in the best way, I have to admit. What we got going here. Okay, in the last video, one of the last things I talked about was the dangerous area in a device like this. And so right away, you open this up right away. Danger high voltage inside here. And this anode connection to the side of the display tube. This thing's going to have a few thousand volts on it, and that voltage is developed in a power supply down this area, I suppose. Now normally an instrument like this, all the high voltage lines are very well protected, so you really can't get your hands on them easily. If you're poking around with a tool, especially shoving it through holes, never do that unless you're sure of where you're going with it, because there are in most of these tube devices, you can get quite a shock off them. If it's a scope with a display tube like this, then we're talking thousands of volts to make this tube operate. So, danger, danger. Here's another area here, up on top. Danger, high voltage. So even these kinds of controls could have voltage on them. Anything up here could have voltage on them. So, in fact, the best assumption is everything's got some voltage on it. So, generally, it looks pretty clean. Not too bad. You notice this guy has a cooling fan, because I think it has 20 vacuum tubes in it altogether. Now I noticed from looking, I cleaned this up, by the way, before I started the video. I cleaned up the outside of it. I didn't open it. I opened it here. But I did notice that this tube is just a real mess. So I want to clean this off before I turn it on, if I'm going to turn it on. Because this kind of debris is going to cook onto the tube. I don't want that to happen. And what is that tube? That's almost certainly the rectifier. That's a... what is that? A 6080. 6080. Well, I'm going to guess that's the rectifier tube. I'll have to look up 6080. So it's bound to get pretty hot. I mean, like, physically it's a large tube. One of the reasons it's large is because it's trying to deal with a lot of heat. Okay. You see a capacitor here, cardboard, but most of them are metal canned capacitors. the quality of the build in Tektronix equipment is really impressive. Really very impressive. We can't see too much here because most of the wiring is underneath here. Let's go around, we'll pop open the other side. I'll bet you that there's many models of Tektronix scopes, and maybe even other equipment, which are extremely similar in how they're designed and built. I know there are some very special. I don't know if I got that off. There are some special things about these scopes. Here we come. That make soldering a special event. So you don't want to get in here with your regular soldering iron. Let me turn on the close-up camera here. We'll scan around a little bit now that it's all opened up. So just going across the bottom here. Oh, I've got the focus way too close. Hang on a sec here. I'm going to be back a bit so you can see a little more of it. And back further. Something like that. Okay. So just like the other scope, here's a complex switch here. That's what I'm turning. There's those capacitors that are so unreliable. Yeah, I'm sure this is built with high quality components as best they could. All these adjustments here. Okay, a little bit of cobwebs happening in there. Great big transformer sitting here. It says Tektronix on the top of it. Lots of calibration adjustments. Oh, the debris in there. What is all that? It's like a... Hey, has something been living in here? Know exactly what that stuff is, but as I say, I've been pretty much ignoring this guy. Here's a, looks like a whole row of diodes, another whole row. Ooh, oh, full of cobwebs back here. Here's the fan motor. Something I noticed about the motor we'll look at in just a moment. Ooh, there's a big selenium rectifier here. Never had it happen to me, but I've certainly heard that if you burn one of these eventually fail. These selenium rectifiers with all the fins on, they eventually do fail. And when they do, they release a smoke which is so bad, it'll literally chase you out of your house for a month. So I've heard. So typically, these guys get changed out with modern diodes. That's kind of weird. That's got the diodes here, but they use this selenium one on an instrument like this. Okay, now the fan here. Pretty good, but if you look at the rubber mount, look at the rubber mount. What is going on with that? Not sure what to make of that. It looks weird though. Seems okay. Spins fairly well. I don't think it's jammed. Now, here's another feature of a scope like this. These things, which are coil after coil after coil. It goes up the side here too. So those are delay lines. And they have to do with coordination of the signals reaching the tube, the display tube, because at high frequencies you can get a little bit of phase shift and stuff like that, and the result is you're not going to see on the scope what you really need to see. You're going to see, instead of the thing you're testing, you're going to see the scope itself. You know what I mean? There's a great big honking molded capacitor there. thermal cutout. 137 degrees, that's no doubt Fahrenheit. If that's centigrade, wow. Lots of adjustments sometimes with the values written right by the device. Look at all the adjustments in here, oh my gosh. Now, special soldering issues. So you see kind of an unusual way in which the components are laid out in here. They're laid out between these, I suppose, are porcelain supports, and the components are soldered in these little grooves here. But this is not ordinary solder. There's nothing ordinary about this. So there's a very specific solder required to work on this stuff, and if you just try to do things with ordinary solder, you're going to get into big trouble. So now I don't have any of that solder, so I won't be unsoldering any of this, but then I don't really, well, I'm not sure what my intentions are with this guy. Probably the same as the Oscilloscope. Check it out, see if it works, understand where we are. There's the light bulb for another one over there. So I just sort of have a checkout notion as to what's up with this. Lots of tubes in here. Everything looks okay, a little dusty. Okay. Switches seem cleaner than the last one. But like I say, last time I operated this, it came on. Seemed to work for a little bit. And then not. Okay, so if you'll just bear with me for a moment, I'm going to get a cloth to clean this tube. We'll plug it back in, we'll turn it on. Why not? Okay, I'm going to clean off the number if I'm not careful. Wipe the number right off the tube. Just want to get the bulk of that dirt off it because it's going to set off my smoke alarm. Just kidding. Okay, pop that back in. Is everybody ready? I certainly am, or not. First, where's the on-off switch? Oh, a big toggle switch right here. It's a little loose. Switch is off. Focus, intensity turned down, astigmatism in the middle, scale illumination, I'll turn it down. None of the other settings really matter. We're just starting up. Let's see, vertical in the middle, horizontal in the middle. Has two inputs. I'll set it to AC on this input for no good reason. We'll turn the volts for division so it's not very sensitive. And square wave calibrator. Oh, that's interesting. That's great. That's for compensating for problems with the probes. Make a quick test using this. Calibration out. That might be useful on other things. All I gotta do is lug a 65-pound machine around with me. I think we're set. I think we're ready. Okay, so take the power cord here. Power's off on the panel. Plug it in. Yeah, I found that on the scope. I can always use these connectors. That's great. It's been on the scope for since 1995. Tucked away. Switch is off. Where's my fire extinguisher? I don't have it in here. I actually have the fire extinguisher near my fireplace. That's a good place for the fire extinguisher. Okay. I'm a little nervous doing this, of course. Just double checking everything here quietly. Remember, the intensity is down, so we're not likely to see anything here right off the bat. But if it's going to do what it did last time, 20 years ago, it's going to come on, look okay, and then it's going to fade out. Now, I'm going to make sure this thing is triggering. So it will trigger the display, we'll see it. So hopefully there's a line trigger switch here. May not be. That's the sweep. There's the trigger input. Here we are, line. Yeah, okay, so we'll put on line. That means it'll trigger on the 60 cycle power coming into the scope. So it will trigger for sure, as long as I have these triggering level controls good enough. Doesn't need a real signal being fed into it. Otherwise, if it doesn't trigger, it may not show. It'll look like it's not working when in fact it is. I think we're ready. Okay, with this switch off, power on. Watch these light bulbs. I think these are really going to go this time. This is a big machine, so my guess is they're going to look like they're on full blast, which is fine. We all set? Ready? Let's get your eye on the switch. Well, you cannot, but you'll see my hand going over to it here. Here we go. Woo! Bright lights, very bright lights. Let's see what's happening inside here. Okay, so a number of neon bulbs have come on. Now, with this kind of restriction, it may take a long time for this thing to get going. The fan is starting to turn. As the initial load goes down, the amount of voltage goes up being applied to it. So it's usually not too good to run a motor at low voltage. So I'm going to let it be like this for a minute here while we look at it. I'm listening for sounds. It looks like none of the tubes are lighting up. That's what it looks like. Oh no, I can see this one's lit up. Here, let's just turn this off. And that light over there. Yeah, now you can see that tube's lit. Okay, there's probably no chance of seeing anything on the scope screen, but let's check it out, just in case. So, turn the intensity up. Nothing shows. Okay, I'll leave it turned up. How about the scale illumination? It's not working, or there's just not enough power in this set yet. I'd be stunned if we see something on the screen, but I need to look. What else can I adjust? Trigger level. Yeah, there's nothing showing up. Okay, now we have to take the bold step of applying full power. So we're going to jump this thing up from probably 60 volts. It's going to go all the way to 120 full power. If anything really seriously wrong, I'm depending on the fuse in my house to help me out here. Okay. You feel lucky? I feel lucky. Let's let her rip. Ooh, that sure made me jump. Okay, the tubes are really lit up now. Let's get the close-up camera going. Fan is going. Okay, so this is going to look pretty cool in this camera. So yeah, that is a very bright tube there. Behind it you can see, coming this way, okay, that tube there looks like a voltage regulator tube, maybe the same kind I need for the signal generator. It's quite possible. I'm looking for anything out of sorts here. How about light in the tube itself, the heater and the tube itself. Keep in mind here, I do not want to stick my fingers in here or shove this camera in too deep. What's on the screen? Oh my gosh! Look at that. Quickly. Look at that. Have a look. Presto! Now, it faded out last time. You know, maybe I did something stupid to it last time. That happens occasionally with me. Turn it down the intensity a little bit. Wow, that looks really good. Hey, let's do that signal thing again. Remember what I did with the lead wires here. We'll feed in a signal. This is, hey, boy, I tell you, if all my repairs went this way. I'll connect this to. How are we going to do that? How are we going to do that? A little harder to use these clips to connect this. So the ground can go here. And oddly, you can go. Try to go there. Okay, I need another banana plug. Not quite ready. Another screwdriver. Okay, good shot. Screwdriver sticking out of there. Signal going in. This is set to AC. Vertical sensitivity is very low. Let's turn it up. No signal appearing yet. Why would that be? Why would that be? It'll be because there's no signal coming out of my signal generator. Okay, let me fiddle with the signal generator control here and try not to block the camera view at the same time. It's a little tough to do. Fortunately, I have to get the other scope out now and see if there's really a signal there. No, I don't. I can measure it with this meter because I know what happened last time. Last time we saw 4 volts, I think. Nothing there, nothing there. Happened. Okay. I have to prove there's a signal going to the front of that scope. So I'm going to clip my voltmeter on here because I think it's an intermittent coming from the intermittent problem with my signal generator. Just get my meter clipped on so I'm not holding on to it. Okay. Now I'm going to wiggle some of the controls on the signal generator, hopefully get a reading here. Well, you know what? We're going to go up in frequency. I've definitely got a signal going into the scope now. Okay, disconnect that. I'll leave it on. No harm leaving it on. Now, still seeing nothing on the scope. Where'd it go? Oh, you know what? I was busy fiddling around not watching the scope. Did it fade out? Oh, crying out loud. I have to watch my own video now to see what happened. Did I move it up somehow? I should have been watching more closely. Okay. Too busy looking at other stuff. So we're still on line trigger. Trigger reset right in the middle. Does not appear to be triggering. I missed my own. I missed it. Well, intensity right up full, but not quite full. Up so high that if it works for a moment, I'm bound to see it. Pull this out because it worked before. So yeah, you know what? See, so I think it's done what it did before and faded out. It's just I wasn't watching when it happened. Phooey on that. Well, at least I got it on video. You saw it work for a moment. Now that can't be. There can't be a lot wrong here causing that. It could be everything from a loss of high voltage to the picture tube, to bias problems everywhere. It could be anything beyond that. Maybe a bad voltage regulator. Wouldn't that be funny? Okay, but that's about all I can do right now. I'll have to let it sit, and then we'll start it up again and try and get a display, and then I'll keep my eyes on the display. In the meantime, I'll watch back the video. Switch it off. This guy's a bit of an energy pig though, I think, with 20-something tubes in it. Probably 150, 200 watts anyway. Let's take a look. Front nameplate data. Well, I don't see a nameplate with any data on it, so we'll just have to guess with that many tubes, especially with some of them glowing pretty bright, especially with a big cooling fan in the back too. Okay, that's as far as we're going to get with the scope at the moment. Thanks again for watching.